This video is on Unit 4, Chapter 8, Intro to Polynomial Functions, Lesson number 3, Remainder and Factor Theorems. So in this lesson, we are going to look at two theorems. One's called the remainder theorem. One is called the factor theorem. In both instances, we are going to use synthetic division to answer questions based on these two theorems. The first theorem that we're going to look at is the remainder theorem. You might also hear me call it synthetic substitution, but it has its basis is from this remainder theorem. We're going to use the remainder theorem to evaluate polynomials at a given value of x. And the second bullet is really confusing, but this is the remainder theorem. Let f of x be any polynomial of degree greater than or equal to 1, and let a be any real number. If f of x is divided by the polynomial x minus a, then the remainder is f of a. So that's what the remainder theorem says. In a nutshell, this last bullet tells you what you need to know. When using synthetic division to evaluate a polynomial, again, we are evaluating, the remainder is the answer. So, looking at these examples, the directions have been left off here. So let me write this in really fast. We are going to use synthetic substitution to evaluate each polynomial for the given value. Now, when you were first introduced to evaluating, basically all you were told to do would be to substitute the number in. We're going to use synthetic substitution instead. So looking at example number 1, it says f of x is equal to x cubed minus 4x squared plus 3x minus 5. And we're going to evaluate if x equals 4. So again, what you used to do was substitute that in, the 4, x equals 4, into the problem. But again, we are going to use synthetic substitution. Notice here that it already says x equals 4. And when you think back to lesson number 2, when we started synthetic division, we had to start out by taking the divisor and making it say x equals. Well, this already says x equals. So we're going to take that 4 and we're going to go ahead and put it in the box. Then we're going to use our synthetic division and just the coefficients, so cubic, the quadratic, the linear, and then the constant terms go in order. Bring down that first term. 4 times 1 is 4. Add, and you get 0. 4 times 0 is 0. 3 plus 0 is 3. 4 times 3 is 12. And negative 5 plus 12 is 7. So what that means is when x is 4, you get 7. So the input is 4, the output is 7. Let's look at number 4. P of x is equal to negative 3x to the 4th plus 3x squared minus 9, plus 9. And I want to evaluate if x is equal to 2. So again, it already says x equals 2, so the 2 goes in your box. Now, there are several missing terms here. And just like with our synthetic division lesson, you have to hold those spots if something's missing. So my quartic term, my x to the 4th term, is a negative 3. Next should be my cubic term. There's not one, so I'm going to put a 0. Next comes the quadratic term, then the linear term, which there's not one, and then the constant. So if you think in terms of that vocabulary, hopefully you won't miss a term that's missing. It's not there. You'll remember the 0. So we're going to bring down the negative 3. 2 times negative 3 is negative 6. 0 plus negative 6 is negative 6. 2 times negative 6 is negative 12. 3 plus negative 12 is negative 9. 2 times negative 9 is negative 18. 0 plus negative 18 is still negative 18. And then 2 times negative 18 is negative 36. And then 9 plus negative 36 is going to be a negative 27. So P of 2 is equal to negative 27. So that is your synthetic substitution or your remainder theorem. So the next one I want to look at is your factor theorem. The factor theorem is an extension of the remainder theorem. If x minus a is a factor of the polynomial f of x, then f of a is equal to 0. So the remainder here has to be a 0. Your factor theorem links factors and roots of a polynomial. So if your factor is x minus 2, that means that when you substitute in a 2, when you evaluate for x equals 2, you should get 0. Because your factors give you the roots. If a number is divided by any of its factors, the remainder should be 0. So the directions here tell you to determine whether the linear binomial is a factor of the given polynomial. Again, the bullets there might have been a little confusing. So let's think of it in terms of just plain numbers. If I said 4 is a factor of 12, you know that 4 is a factor of 12. But the reason why 4 is a factor of 12 is because 12 divided by 4 goes evenly with no remainder. 12 divided by 4 is 3. No remainder. So if things are truly a factor, they divide in there evenly with no remainder. So what I'm looking for here when I use my factor theorem is the remainder 0? So let's look at number 7. Number 7 says, is x minus 1 a factor of f of x equals negative 2x cubed plus 3x plus 4? So notice how this is given. It's given to you as a factor. So you're going to take the x minus 1, set it equal to 0, and make it say x equals. So I got the 1 in the little box. Our function says negative 2x cubed plus 3x plus 4. The cubic starts out from cubic. The largest exponent is a 3. So I got my negative 2. The next one should be squared. Our quadratic term, there's not 1, so I'm going to hold it with a 0. Then the 3, which for your linear term, and then 4 is the constant term. Bring down the negative 2. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. 1 times negative 2 is still negative 2. 3 plus negative 2 is a 1. And 1 times 1 is 1, and 4 plus 1 is 5. So because the remainder is 5, x minus 1 is not a factor. It doesn't divide evenly. Let's jump to number 9. Number 9 asks you, is x plus 4 a factor of g of x, which is 2x to the 4th plus 8x cubed plus 2x plus 8? So again, it's given to you in factor form. You want to write it in a root form. So again, this is your x plus 4 is a factor, right? And then when we say x equals negative 4, this would be in root form or solution form. And in order for that to actually be a solution, and in order for x plus 4 to be a factor, the remainder has to be 0. It has to divide evenly. So the negative 4 goes in the box. My largest exponent is a 4, so there's my quartic term. Then comes cubic, then comes quadratic, then linear, then constant. So there was a missing term there. Hopefully you didn't miss it. bring down the 2. Negative 4 times 2 is negative 8. 8 plus negative 8 is 0. Multiply, you get 0. Add, you still get 0. Lots of zeros here. Negative 4 times new is negative 8. I got a remainder of 0. So what that means is that x plus 4 is a factor. And it is a factor of that g of x function. So those are your two theorems. Again, factor theorem is you're looking to see if something's a factor, knowing that the remainder would then have to be 0. And then your remainder theorem, the remainder is the answer because you're evaluating. So again, those are your notes for chapter 8, lesson 3.